First, the product introduction of our existing products and our new products. This presentation contains the following items. First of all, I will want to tell you something about our general machine vision platforms, what we see in the market. Then our Delta product groups, different kinds of products below each group. And then I zoom in to our products, what we have already and what we will get very soon, and to see what kind of possibilities we have for you. First of all, what we see in the market. In the market, you find three different kind of systems. The first one is the PC-based system. That means the software runs on an industrial PC. Camera is directly connected to the PC, cameras in the field, and the program is made directly on the PC. It is a very flexible system because, of course, you can do more on that PC than only the machine vision, but it is also a very pricing system normally. Second one is the smart camera. That's just the opposite. A smart camera is a camera with standard, the software inside. It is more price comprehensive, so you don't need external components. You can only use the camera with a power supply, and it gives you directly the information out what you want. Of course, there's also some limitations with this. Not all kind of software is usable on this kind of cameras. So it is normally only used for simple applications and not for very difficult applications. The third one, what we see in the market, are the standalone vision systems. That means you have a more or less a complete system, a controller, a camera in the field, and that controller is running the software. That the output can go to your PLC, and for further investigation, but the checking will be done directly in this controller. This is more or less the most cost-efficient system because most of the time you have also possibilities to connect more than one camera to one controller. So that means you have more possibilities and also more checking possibilities in that case. Where we can find machine vision, you can find it for measurement, of course, measurement inspection. If you have a bearing, for example, you can measure the outside dimension of the bearing. You can also measure the balls inside of the bearing. Just an example. For inspection, you can check on the defects. You can also do the packaging inspection. You can recognize patterns, product inspection. So there are a lot of possibilities with this kind of machine visions. Guiding, of course, robot guiding. Machine vision is most of the time in combination used of a robot, but you can also think about part tracking and guidance of packaging on the conveyor belt. Identification, barcode reading, QR code reading, but also reading of letters and characters for verification to check if your code is right on the package. The next step, that was what we can find in the market. The next step is our Delta machine vision groups and possibilities. From the past, from the last years, you know already the 2D inspection, the standalone units. But what we have also launched this year is the 2D robot guiding PC software, the VGR software. We have also some possibilities for barcode reading, handheld, fixed mounted, but also a vision sensor. And the third one, what we are start promoting now, is a 3D solution, the all-in-one and the TOF camera, for example. First of all, the DMV series. Depending on what kind of performance you need, you can start with a DMV 1000. That has the lowest performance. It is based on grayscale. It has you can control it with a keypad simply, and it has all the basic functions what you need. It is the It's a very good system, but the speed is less than the others, of course. The opposite is the DNV2000 that has the highest performance. You can connect 4 cameras maximum, and you can connect also grayscale and color cameras. In the middle, there's the DNV3000. It's the new one released middle of this year. It's based on GigE controlling between the camera and the controller, and it has also the same basic functions as the other two. You can only connect 2 cameras, grayscale or color. So that means the performance is just in the middle of the other two. Just a small overview of the product family. DNV1000 only connect 2 cameras, grayscale, 0.3 megapixel, 0.8 megapixel. The communication between the camera and the controller is based on FireWire and, of course, I/O on site, RS-232, 485 and Ethernet communication. In the middle of DNV3000, it is possible to connect 2 cameras, 0.3, 1 megapixel and 2 megapixel. The communication between the camera and the controller is based on GigE. The distance between the camera and the controller can be roughly 20 meters. And you can connect color and grayscale cameras. The third one is the DNV2000. You can connect 4 cameras to it, and you have more possibilities, the 0.3, 2, 4, 5 or 12 megapixel in grayscale and color. The communication between the camera and the controller is based on camera link with a maximum length of 8 meters. So depending on your application and the distance between the camera and the controller, you can choose for one of these. Also, the amount of cameras, what you want to connect to one controller, can be a choice for the different DNV controller. Small overview of the communications between the camera and the controller. DNV1000, the control between the camera and the controller is based on IEEE 1349. That means FireWire. We can only connect 0.8 and 0.3 grayscale camera. Then we have the DNV3000 based on GigE controlling between the camera and the controller. Only possible to connect the 0.3, the 1 and the 2 megapixel camera in color and grayscale. And at last, of course, the DNV2000 based on camera link with the 5 possibilities for connection the cameras, 0.3, 2, 4, 5 and 12 megapixel. The controller is available in 2 or 4 supporting models. All 3 controllers have basically more or less the same functionality inside. So you can make your program with the same function blocks. Only the way how you control it is a little bit different, and also the layout, what you see on your screen, is a little bit different. DNV1000 is controlled by a keypad. DNV3000 and 2000 are controlled with a mouse, more or less Windows based, looks like. But the function blocks inside are more or less the same. What you can do with the DNV series, of course, you can try to find edges. You can measure the width, you can measure the angles between edges, count edges, pitches, position, the height of a trace. But you can also do shape matching, check on shapes. You can also area checking. That means you are checking how many pixels, black or white, are in an area. Intensity, blob. Blob is a cluttered group of black or white pixels. Stain, OCV, verifying characters, but also barcode reading, 1D or 2D. That are all the functions that are standard available in all the 3 DNV controllers. Where can you use it? Of course, there are a lot of different kinds of application fields. Here are some mentioned. Counting, of course, bottles, caps of bottles in a crate. Pick and place with a robot. illumination inspection, character inspection of an LCD screen, you name it, and you can do it. Depending on what you want to do, you have to choose, of course, the lens, the lighting, and the camera and the controller. The second part is our DiaVision software series. That's new since this year. We can provide you 3 types of different software. The first one is the VGR software. It's the Vision Guided Robot. It is a software package what you can run on an industrial PC or a normal PC, of course. In that PC you need the possibility to connect a camera. The camera is based on GigE in that case. Our industrial cameras can be used, but they are at this moment only available with power over Ethernet. So you need a special card in the industrial PC, or you need an injector that you can create the power over the Ethernet. The functionality of the DiaVision VGR software is more or less the same functions block as you find in our controllers, but it is more easy to do the coordination with the robot. That's why it is called Vision Guided Robot. It not only you can not only use the Delta cameras, industrial cameras, but also use other brands if it is based on GigE. The second software package what we can provide is the DiaVision IDM. And the IDM software is the same as the VGR software, but now it's including barcode reading and OCV. And this barcode reading and OCV reading is based on very high speed. That is where we can use it for. It can be used in food and beverage, packaging machines, and so on. It has very good references. And of course, the third one, if you don't want to use our software version, but you want to make only want to use a part of it and make your own software, you can use our library. In that library, you find our function blocks, more or less, what you can use in your own software. Some applications, of course, in combination with our Scala robot, you can do it. You can use our PC. It must be a 64-bit controller. That can our PC, Delta PC, but it can also another brand, of course. You can directly connect the GigE camera to it. If you use an extension card, of course, because it's based on power over Ethernet. And then you have already a complete system. The other way is, of course, that you can create more or less a complete system with 4 cameras that you can measure every corner on an XY table. Some ideas, you can run it on our IPC PPC. In that PPC, you put a frame grabber card to create power over Ethernet, and you can directly connect your camera to that power to that frame grabber card. If you don't want to use the frame grabber card, you can also use the Ethernet output, and then you have to use a power over Ethernet injector. You can also use our AX8, new AX8 motion controller, but that controller has only Ethernet, not power over Ethernet. So you need to use a power over Ethernet injector to inject the power on the cable. And the third one, of course, is the MH1. You can put our frame grabber card in it, or you can use, of course, also a power over Ethernet injector if you don't want to use an external card. A frame grabber card we can provide you with for connecting 2 cameras or 4 cameras. What is very important, because it's VGR software, it's vision guided robot, means that we have a very clear setup in the software for connecting the robot itself. And also the points where you have to check, where you can check the outline points of your field of view. You can easily connect to your robot that is made, especially made for it. In the software, you can find also a correction possibility for your lens. Depending on the quality of the lens, you can have distortion, of course, at the side, outside of the field of view. In this software, there's a possibility to correct a little bit of that distortion. If the distortion is too big, of course, then it is not possible. And this distortion is depending on the quality, of course, of your lens, what you are using. We only use high quality lenses, so our distortion is most of the time not so big. And the little what you have, you can correct with this software. Smart camera. Of course, as you have seen, this is another point what we have, what you see in the market. At this moment, we don't have any smart camera series, but it will be available beginning next year or end of this year. It is a very small smart camera, and the software inside will be based on our VGR software. That means you have a lot of possibilities what you can do with this new camera. It will be available in grayscale at this moment first, of course. Maybe in the future it will be also available in color, but we have to check. Communication is based on GigE, so that means if you want to connect to an PC or PLC, you need GigE communication. And the sensor type that is inside is based on a global shutter. That means you can reach high speed with this camera. It has a very high resolution also, and it has a 2/3 inch sensor inside. It will come end of this year, beginning next year. Of course, the one what we have already for a few years in our package, for checking, is the VIS sensor. It's a sensor, it's not really a camera system. It is a sensor based on camera functions, but it has not so much functionality. We have 2 versions. Version 1 is you can read barcodes with it, and the other one you can use for blob checking. Blob checking is only checking on black and white pixels, no more. For the barcode reading, you can read the 1 and the 2D barcode. Some applications, of course, there in the sensor itself is a flashlight available, so we can do a very high-speed checking. Not always is that light enough, so then you need also external light. You can check on defaults, for example, in a PCB, small defaults, checking that is based on the blob function. But you can also read barcodes on a product somewhere on your product itself or on the package. 3D solutions. We are starting promoting now at this moment 3D solutions. This one we will have end of Q1, Q2 next year. It's a 3-in-1 3D version, and it is based on 3 different types of technologies combined in one package. In the few years ago, we showed already on the SPS fair our structure light solution and also our stereo vision solution to see the depth of packaging, devices, shoes, and so on. And these 2 plus an align scan is combined in one 3-in-1 vision camera, 3D camera. It supports different types of applications. Dimension measurements, of course, boxes, shape measurement. You can also check on defects, object detect and matching. It supports Ethernet protocols. Of course, you can connect the display on it and an external trigger. So there are many applications what you can think about. Here you see the viewer, what we have. This is a fan inside iPhone. Also there is a fan inside. And with this 3D camera, you see clearly the marks on the fan itself and also the fins. The second one is the TOF camera. We are already starting promoting it. TOF is time over flight. That means you send out the signal, the light signal, and you are measuring the time that it takes before it comes back in your camera. It is an easy to use. It can be used in agriculture, logistics, but also AGV. At this moment, we are only providing custom-made products, but beginning of next year or end of this year, we will have our general line available. Some applications where you can think about cow milking, auto milking, but also you can use it for pick and place, palletizing with the robot. You can directly measure the size of the boxes. You can also use it for AGV guidance of robots, simply guidance, but also checking and positioning for the robot to find products in the basket. The next one is barcode scanner. You know already, of course, our handheld barcode readers. We have also the fixed mounted, the DFS 131, based on 232 output. And what is new, what is coming end of this year is the DFS 150, and that's based on 485 communication. All our products can be used for supporting the codes, what is mentioned here. A lot of different types of barcodes and types, all are using the same barcodes. And also for the fixed mounted and the new one, the DFS, will be available soon. You can use it for retailing, logistics on the boxes, manufacturing to read the barcodes on the package itself, but also for medical applications, depending on what kind of barcode there is used, of course. The fourth group is our industrial camera. It's also new. At this moment, we have only the DNV GT series. The resolution is 0.3, 1.3 and 2 megapixel at this moment. And the power source is power over Ethernet. It can be used in combination with our DNV VGR software, but it cannot be used in combination with our DNV 3000. That has a different protocol. What is coming next is the DNV C series. There we have more possibilities in resolution. It starts, of course, with the 0.3 megapixel, but we will finally get up to 20 megapixel. So we have much more possibilities with this one. It will be available with a global and a rolling shutter. The difference is, of course, the type of checking inside of the camera. At the right upper corner, you see more or less the difference. The rolling shutter means that we divide the picture more or less in rows, and you check every row after each other. And the global shutter, then you check every row in once. That means you can, if you have a moving object with a rolling shutter, you have distortion on your picture. And when you have a global shutter, you have the straight picture, what you see also. Where you can think about this, you can, of course, you can use it with your own application if you make your own software. And you can think about industries for conveyor checking, robot checking, inspection, measurement, and so on. You can use our library for it to make your own software. But you can also use it in the food industry for quality control or counting, logistics, barcode reading, and inspection. Some specifications, of course, it's very small, the housing. It has, of course, some external I/O. You can connect it directly to your computer, and then you can set via inputs, your triggering, and also some outputs. It is used power over Ethernet, what we have now, and the one what's coming has also an external power connection. It's more efficient to use it with all types of IPCs in that case. Here you see the mechanical outline of the camera, more detail. What you see here with the power connector is just the new version, what is coming. The version what we have now is without that power connector. This is the end of this presentation. Then I go over to the next one. I have to switch over to the next presentation. Hopefully it's working. Okay, the next presentation is about lenses. Where you find lenses, of course, every camera what you use is using lenses. You can use also filters on the lens itself. It has a very different, you can use it in very different applications, of course, but also lenses are used not only with machine vision, but also with a standard camera, but where you can use it. And depending on what kind of lens you have, you can use, of course. We have 5 different types of lenses. We have an entrocentric standard optic for normal use, telecentric measuring lenses for precise measuring, color corrected lenses, zoom lenses, and macro lenses. The last 3 are most of the time not used with machine vision. It makes no sense to do that. So I only focusing on entrocentric lenses and telecentric lenses. Okay, type of lens. What you want to do with the lens is to create a kind of field of view connected to your camera. Depending on the distance between your object and your camera, your field of view will change with the standard lens, of course. And depending on the sensor size, you can have also a different field of view. Working distance, of course, has influence on your object. If your working distance is fixed, you can choose another lens, and then your field of view will change. So it's easy to calculate your focus length if you have a certain field of view and a fixed working distance. You can have also you can also use a different wavelength of light, but depending on what kind of wavelength you have, it has influence on the impact of your camera. Entrocentric lenses, that's the most standard lens what we have, of course, and we have different types of focus lengths available. This is the most common used, and if you change the working distance, your field of view will change. These lenses are available for each type of camera, and based on what type of camera you have also a type of lens available. Depending on what type of lens you are using, you have also a different depth of view that helps you for checking. Depth of view means that in that working distance range, you have a clear view. If you have a small depth of view, means that you have to create a very fixed working distance to have your clear view. If you have a large DOF depth of view, you can play a little bit more with your working distance, so then it is not so accurate. A little bit about the angles, what we can use with the lenses. A telecentric lens has an angle lower than 20 degrees. A normal lens is between 40 and 55. And if you go to wide angle lenses, then it's up bigger than 55 degrees angle. Fish eye we don't use with the machine vision. That makes no sense to do. Your field of view will be very large, but also you get a lot of distortion of your device in your camera. So depending on your working distance, you have a field of view. That means your amount of pixels will be the accuracy what you will get on with that combination. You can easily calculate, of course, how many what the working distance is, or if your working distance is fixed, what kind of focus you need for your lens. This is how it looks like inside your lens. The image in the camera is the B. The field of view is your object, what you see finally, have to see finally. The focus length is inside the lens is important because that is the distance between your focus and the lens itself. And of course, the working distance, that's the distance between your object and the lens. This is how it looks like. Entocentric lenses are the less expensive versions. With these formulas, you can easily calculate your working distance or your field of view or your focus for your lens, what you need. Okay, with this kind of standard lenses, of course, you don't see all the time the same. It has effect. The focus distance has effect on your field, on your view, I must say. At the right side, you have a lens with a focus of 6 mm. You see not all the middles of middle circles straight. If you use the same picture with a focus lens with 25 mm, you see it already more straight. If you want to do measurement, really accuracy measurement, you have to use a telecentric lens and not a standard lens. Typical applications, most of the time you use a standard lens just for checking, for counting, barcode reading, and so on. This is the most used lens what we have for machine vision. You can have also some accessories. You can have rings, focus rings between your camera and your lens. With that ring, you can extend the distance of your focus without choosing a different lens. This can be helpful if you need a focus what is just between two standard focus devices in. You have also aperture rings. With that one you can change more or less the image what is getting into your camera. The opposite is the telecentric lens. You see it already in the picture. Telecentric lenses are special lenses, are also expensive. It is depending on the lens itself, what is your working distance, and also the size of the lens is already, your field of view is already fixed. You cannot change it anymore. That is chosen by choosing this lens. Of course, here you see the difference. if at the left side you see the sub-D connector, if you look at it with a standard lens, entocentric lens, at the right side you see it with a telecentric lens. That means you see only the top of the pins inside the sub-D connector. At the left side you see also already some of the side of each pin when it is going to the outside of the lens. This is the big difference of both lenses. So the telecentric lens will be used for high accuracy measurement objects. The entocentric lens, the standard lens, can be used for most of the time or the rest of all applications. As I said, the field of view is fixed for each lens, what you buy, what you see, but also the workings distance is already fixed. The depth of view is also fixed. So you cannot play anymore with workings distance and your focus. It is already done in the lens itself. So when you have a telecentric lens, you have to check in your datasheet what is the workings distance between the lens and your object, and you have to mount the lens and camera on that distance. Inside you can have, of course, 2 or more lenses to create the straight beam outside, because that is what you are creating. The price of these lenses is depending on the amount of lenses what is used inside the telecentric lens, the telecentric tube, but also depending on the quality of these lenses, of course. Not always more lenses is in higher quality, but depending on the quality of the lens itself. So where are we using it? We use it for measuring, high accuracy measuring. Of course, you can also use it for a position. If you have a very high accuracy position, what you need, and you have to reproduce that, then you can also use a telecentric lens. Most of the time when you use a telecentric lens, the field of view is small, because when you have a large field of view, that means it will also cost a lot of money, because the telecentric lens will be more expensive in that case. And also you can use a telecentric lens if you have to inspect holes somewhere, because then you have the clear view of the hole itself and not see also the side of the hole. This is depending on what you want to see, of course. In general, for high precision measurement, you use a telecentric lens. Then I'm going to look for the third presentation, and that's about light. Okay. This is a presentation about light and light sources, and also what kind of vision light we have and what we can use and where we have to use it. Of course, from the beginning of machine vision, a lot of years ago, we used different types of light sources. Nowadays, most of the time we use LED, because that has the most homogeneous wavelength what we can use. In the past we used also xenon lighting and also quartz lighting and halogen, not a standard bulb, because that has also the influence on the 50 Hertz, and that you see directly in your camera back. So also here you see, depending on what kind of wavelength you need, you can choose for a different type of lighting. The most interesting is nowadays the LED. Okay, where you have to look for when you have to choose for a light. Of course, first of all, you need to check the light source itself. What kind of light do you need? Do you need indirect light? Do you need backlight or whatever? Also the wavelength, depending on what kind of product you have, you can play with the wavelength of your lighting, and in combination with filtering, you can have the best detection in that case. Also, depending on what kind of surface you have, of course, do you have a lot of reflection, or is it rough, or is it smooth material? It's all that kind of information is important to know before you are going out for lighting. And also the speed, of course. When you have a high-speed moving device, it's not always simple to use a standard light, but then you have to think more or less in strobe light. And you have to take also the environment considerations. Is there a lot of white light, natural light available on the place where you want to detect? Then you have to do something with covering or with filtering. So depending on what you are choosing, it will also have a cost. What is the main objective? Of course, what you want to do is to maximize your contrast with your device for checking and the background. That is the only thing what you want to do. What you also want to do is to minimize the rest outside of your object. And you don't want to have a lot of influence of ambient light or two different light sources, what can have also influence on each other. Normally we use only visible light. It has a small spectrum, of course, that's between 400 and 700 nanometer. That is what we can see with our eyes. But you can also think about UV light, that is between 10 and 400 nanometer. If you have, for example, to check a glue and there is a substance inside what reflects on UV light, then you can easily do the checking with this kind of UV light. You have a real contrast with the back, and so it's quite easy. The same for infrared light. It's between 700 and 1100 nanometer. It's the opposite. And also that one you can use if you don't, if you have more reflecting or more high difference between some components. In the visible light section, you can have also use filtering in that case. If you want to check something red and you use a red filter, your view will completely change. But also the opposite. If you don't want to see the red, but only, for example, blue, you can do it also with that kind of coloring. Coloring and filtering can have a very good reference in that case. What kind of lighting do we have? Of course, you see here already a lot, different types. We have bright field, dark field, backlighting, coaxial lighting, structural light, diffused light. Of course, you can use a dome, but you have also a flat diffused dome. You have different kinds of light sources, and depending on what you want to see, you are choosing the light source itself. If you have the camera at top and the object in the middle, you see in this view where you are, in what kind of light you have, front bright field, the dark bright field, but also the back dark field and the back bright field section. Depending on where you are, you can use a different type of light to create a better contrast on your object. Bright field, then the light is more or less in the same direction as your camera. You can think about ring light, for example. It gives a good result, but it can have also problems when it is a rough structure on your surface, or it is highly angled or something like that. So for diffuse, for flat and smooth surfaces, it works perfectly. The dark field, that is a smaller angle between your object and your camera. It generates lower contrast, but depending on what you want to see, of course. You can create, with that one, you can create light back in your camera on things what you want to see, what you normally not see if the light is coming from the front. Backlight, also this one is very famous, of course, especially when you play with the color of the backlight also, then you can do also very high accuracy measurement without any problem in that case. It is usable for detection with liquids and also bottles. Then you can detect easy inside the bottle itself. Then you have also the dark field backlighting. The normal backlighting, bright field, and it's coming from straight. The dark field is coming from side. So it has only to do with reflection on your object, and the light is coming from the back. Coaxial. Coaxial means that you have the light source from the side and your camera at the top, and the camera is looking to your object via a mirror. So the light is going to your object through the mirror, and then you see directly what you want to see. It is usable for transparent objects, for high reflecting objects. You can use it very good. Structure light. With that one, you send out a pattern of light, and depending on what you get back in your camera, you can see your angles, your object itself. Most of the time, this light source is used for 3D detection, calculating volume. More information about it. Doom light. It is more or less a bulb, a half bulb, what you get. The light is at the ring, and it is sent out via the bulb directly to your object. So it's a very indirect light, and it generates less reflection on your object. So you see clearly with your camera directly on your object what you want to see. The other one is the flat diffuse doom light. Then the light is coming from the side, but you can also have a pattern in it, and with that pattern it makes it easier to work with high glossy items. If you have a lot of reflection on your device and you use a structure, a pattern in your light, then you can easily detect if it is not right on your object. Flat diffuse light from top. It is very easy to use in that case. You have a homogeneous light on your object, so it is not reflecting on your object itself. So you have it directly from top, and it is very useful for a longer working distance. Strobe light, when you have a high-speed moving object, you use strobe lighting. That means you start your light at the moment your object is coming, then you switch on your camera, and you switch off your light when the object is gone. And you do that on a very high speed. And normally, when you have the light completely on, you only see a high distortion on your object, like the letters you can read anymore. When you use strobe lighting, you can read easy your letters and also your barcodes and so on. It looks like if it is standing still. This is how it has to be calculated. Colors. Most of the time your object has also a color, and instead of using white light, you can also use colored light. And with that colored light in combination with filters, you can do a lot. For example, when you have white light on a red object, the red light will be reflected and the green and the blue in the white light will be absorbed. And that's also the difference between the green and the blue, of course, and the magnet and the yellow and the cyan. If you have, so you can play with it. If you have a very red object and you put red light on it, you see it directly with a green or blue filter. You can also create some contrast, because when you use white light, it can be more or less the same color, red, green or blue. But if you have red light, for example, then the red light will be not light up so high, but the green and the blue will light up much better in that case. Also when you check with a color camera, for example, if you have a blue object and you use a blue light, you can easily find the blue object. Here's the vision circle, what we can use. For example, if you have a green object, you can better use a red light. If you have a yellow object, you can better use purple light. Purple light is difficult, of course, but then you can better use the other way around. And also for the orange and blue. So this is the vision circle, what we can use for checking the colors. Also for metals, metal has is very difficult because it is reflecting. And depending on what kind of metal you have, of course, you can use the type of color. In this graph, you see the wavelength of the light. And you see also the colors of what you can see with the different types of metal. For example, if you have aluminium, it is more straight. You can use all colors to detect. But if you have gold, then you can better use the red light for detection. Most of the time, red light is the best what you can use for all the materials. Some examples. If you want to detect the solder balls in a golden pattern, if you use red light, you see more or less everything. If you use blue light, you see only the tin balls, the solder balls. The same below, inside. Okay, not visible, that means ER or UV light. If you have, for example, a transparent bottle and you use normal light, visible light, you see only black. But when you use infrared light, you can see through the bottle, more or less. You see it as this, and you can also detect what you want on the bottle itself, and not only the outside of the bottle. But it's always depending on what you want to detect, of course. Also with colors, if you use it with ambient light, you see the different types of colors, the red, orange, yellow, red, black, blue. With infrared, you only see the balls, not the colors anymore. And sometimes you only need to know what's on top of it, and you don't want to see the difference on your object itself. So that means if it is rough, you can see too much, and with infrared, you have a more homogeneous surface in that case. Another one is UV light, of course. This one is a bearing. In the bearing itself, to see the balls, it's more or less easy to do. You can do that with ambient light. If you use red light, you can see the balls very good. But if you want to see how much fat is used in the bearing, you can do that with UV light. If you have you have used a fluorescence application in your fat, then with UV light you can easily see how much there is in. Filtering, we have of course several kinds of filters. You have a cut-off filter, you have the bandpass filter or a linear polarized filter. The most of the time, if I use a filter, then it will be a bandpass filter, because it is always in combination with the same color of lighting. For example, if you use a cut-off filter with white light, then you can see more or less this. With a white light you see everything. With UV light, without any cut-off filter, you see more or less the same as with white light. But with a UV filter and a cut-off filter, you see the text below, and that is what you don't see with the other two lightings. So with cut-off filter you can create a better view of what you want to see. That's also for text. If you want to read more correct the text on a cap or a tin, you can use a bandpass filter to remove the reflection on the tin itself. But you have to check on the wavelength, of course, in that case. Polarizing. Everybody knows the polarizing sunglasses, of course. Basically, it's the same. It removes reflection from your object, and the reflection of the lighting is always the biggest problem what we have with the camera. If you have too much light or it's a glossy object, then it is very difficult to detect what you want to do. And with the polarized filter, you can remove some reflection so that it is more easy to detect what you want to do. So conclusion is, every product has a different light source. What I'm trying to say with this is that not the camera and the controller are the most important of a machine vision solution, but the lighting is the most important of a total system. I'm now at the end of my training presentation.